Synthetic data could be generated algorithmically. Like you could have some rendering engine rendering the world, and then you're creating synthetic data. Like it could be like a 3D object that you design and you're synthesizing images. We can have some ratio of real and synthetic data, but the most important thing is we need fresh real data compared to just having some ratio of real data. So some ratio of fresh real data is what can actually help us. If we want to compare the amount of real data being generated and the amount of synthetic AI synthesized data being generated, there's more real data being generated. There's no question about it right now.
Hi, I'm Craig Smith, and this is Eye on AI. In this episode, I talk to AI researcher Ahmed Imtiaz about the phenomenon of model autophagy disorder, also known as MAD, in generative AI models. Ahmed explains how consuming their own generated data can cause models to lose diversity and become trapped in artifacts. He discusses experiments on image and text models showing that this effect emerges quickly, though it's not yet clear how prevalent generated AI data is on the wider internet. We talk about the potential strategies to mitigate MAD, including using fresh data and watermarking so generated data can be recognized in training data sets. The conversation provides an insightful look at this emerging challenge. I hope you enjoy the conversation as much as I did. AI might be the most important new computer technology ever. It's storming every industry, and literally billions of dollars are being invested. So buckle up. The problem is that AI needs a lot of speed and processing power. So, how do you compete with costs spiraling out of control? It's time to upgrade to the next generation of the cloud, Oracle Cloud Infrastructure, or OCI. OCI is a single platform for your infrastructure, database, application development, and AI needs. OCI has 4 to 8 times the bandwidth of other clouds, offers one consistent price instead of variable regional pricing, and of course, nobody does data better than Oracle. So now you can train your AI models at twice the speed and less than half the cost of other clouds. If you want to do more and spend less, like Uber and Cohere, take a free test drive of OCI at oracle.com/eyeonai. That's EYEONAI, all run together. That's oracle.com/eyeonai.
Thanks so much for having me over here, Craig. I'm a PhD student at Rice, and I'm also a student researcher at Google right now. So I study the approximation theory for neural networks. So what I do is I think of neural networks as piecewise affine functions, and then I use this theory to see if we can explain how generative models work, if we can like do neural network interpretability, or even say something about like why the neural network has like different training phases, like why we see such training dynamics that we see. So I come from Bangladesh. I'm originally from Bangladesh. I did my undergrad there, after my undergrad, I came here to do my PhD. I also founded, right after my undergrad. So this is also something that's really close to my heart. I have a passion project called Bengali AI, which is it's a nonprofit based in Bangladesh. And what we do is we create data sets and we open source them for research to accelerate research in like Bengali language technology, so LLMs, and also like speech recognition. Those are very primitive in Bangladesh. So
that's interesting because if I'm not mistaken, I've read that Bengali is one of the languages that is underserved in the training data for the big and consequently ChatGPT and some of these don't do well in Bengali. Is that right?
Yeah, absolutely. And it's not only like ChatGPT. Like for Bengali, we don't even have good OCRs. Like it's in development, like OCRs and ASR. These are also like fundamental technology that's required. Especially when you think of Bangladesh, it's like in South Asia, it's so densely populated. So if you have these like groundbreaking technology that can enable people to access technology like in your own language, like if you have a Bengali ChatGPT, you get all the benefits of ChatGPT, but in your own language, which makes
Yeah.
accessibility like it makes it easy to access, right? So that's sort
Yeah.
of like the target that we have, making these models more targeted towards the language specific crowd, so that we can increase accessibility for the speakers over there. Yeah.
Yeah. And one thing I have to ask, your screen name is
Yeah.
Imtiaz. Is what's the naming convention? Because I'm calling you
Yeah.
Ahmed.
Yeah. Yeah, so I have a big name, if you noticed. It's like Ahmed Imtiaz Humayun, right? And the funny thing is, like, Ahmed is a very common name in Bangladesh. So if you look for an
Yeah.
Ahmed in Bangladesh, it's gonna be, yeah, who, me? So yeah, that's why. So Imtiaz is like what I go with. So Imtiaz is my preferred first name. Yeah,
Imtiaz. Okay, great. Then I'll start calling you
yeah,
Imtiaz. Yeah. So you're now at
yeah,
Rice, is that
yeah,
right? And how did this paper come about? And then we can start talking about it. I'm interested in. I don't know if I said it before, but the paper is self-consuming
hmm,
generative models go
yeah,
mad, and mad is an acronym. Maybe you
yeah,
can first tell us what the acronym MAD stands for, and then we can get into the how you came about
yeah,
doing the research and writing the
yeah.
paper.
So MAD is the acronym for Model Autophagy Disorder. So autophagy is a term that refers to like consuming in some like itself, like self-consuming. The self-consumption is like something that is a keyword that has come up in like a lot of different literature. I recognize that it was also like mentioned in Greek literature and everything. So autophagy is the term that we chose to sort of denote this behavior that we see when generative models, when they consume their own generated data, they start behaving like in a non-standard way. Or by non-standard, I mean like something that we do not want to happen. So the way this research, so actually we started thinking about this problem, like I think more than a year ago now. We were, so like we always travel to conferences. Like this idea of um, increased accessibility to generative models would obviously increase the prevalence of generated data, AI synthesized data online, right? And that's what the companies, or that's what we want in general. Like we want people to be able to access LLMs. We want people to be able to access Midjourney or like such technology so that they can generate images that they want, and that's consequently going to lead to more synthesized data online, right? So we've been thinking about this problem, and then at a conference we've been discussing with people, and we see that like there's this general consensus in a lot of people working with large language models and working with big data that we might be running out of data in the future, because like we want to go exponential, and to be able to maintain that trend we need more data, but we don't see
Yeah.
that much data being generated, or like it's very easy to like use up all the data that we have, right? So maybe, and there's also the implications of privacy. So there's this whole research direction called membership inference attacks, where basically you can like this. There are these algorithms through which you can find out if some data was in the training set of another model or not. So if you think about that, if all the data in the world, even sensitive data, is being used to train models, then through membership inference attacks, you could possibly find out, okay, so this sample was in the training data. So this is like true. This is like if I have like maybe some sensitive document ID, right? And then if I can
Mhm.
infer that this ID was inside this model's training data, then we can say, okay, so this should be a valid ID because it was in training data. That's ground truth, right? So there's this
Mm.
whole idea of like these like attacks, or there is this whole idea of like privacy when we're using this data set, right? These data sets. So there are people who want to make like train models in a private manner. So they might also be using synthetic data, like you synthesize data instead of using the real data, so that when those models
Mhm.
are being attacked, like when they send it out in the open and someone attacks that model using membership inference attacks, uh, like it's gonna turn out that this is like these are synthetic data that's been trained on, so it's not gonna matter much. So there's this
Right.
that there are people who want to use just synthetic data to train, and there's also synthetic data going out in the open into the internet, that's like filling up the internet with like synthetic content as well. So and people are running out of data. So there are like these like couple of directions where we see this need for synthetic data. So that the natural question arises that what is the effect? So how differently is synthetic data going to play a role compared to real data because it's not real? Synthetic data has been like so there's like I want to make a distinction. So synthetic data could be generated algorithmically, like you could have some
Mhm.
rendering engine rendering the world and then you're creating synthetic data, like it could be like a 3D object that you design and you're synthesizing images, but that's like one direction. But we're speaking of AI synthesized data because these AI models are getting like they're getting more prevalent, people are being able to use it and generate data. So we're thinking of like AI synthesized data, how what are the implications? So that
Okay,
yeah.
let me just stop to unpack some of that. First of all, on the synthesized and AI generated, do both have this autophagy effect? And I ask because I have a friend from the New York Times that then started a startup AI Reverie and Metabot it, and they were a synthetic data
Mhm.
company, visual data. They were producing entire cities,
Yep.
rendering entire
Mhm.
cities. So does that kind of data have the same effect on a large model as AI generated data, or would the effect be different?
The effect would be so in my opinion the effect would be different because like when you're synthesizing data using like a renderer, then you wouldn't necessarily have this autophagy loop because you don't generate those images and then use those images to retrain the renderer in a sense. So if there are elements in the
Okay.
renderer that do training, that do learn based on the images that are being rendered, so if there's a generative model over there somewhere, then that could be affected by this feedback loop. But in general, like if we render data using these physics engines, it doesn't like that is out of the scope of our discussion.
Right. And the before we go on with it, can you just describe for listeners what is this loop and what happens? And my understanding is that you lose the long tail and the data over time, and you end up with just the mean. But yeah, just describe the effect.
Yeah. So the interesting part is that so this effect basically says that if I want to like shorten these like the takeaways, the effects of like a self feedback loop in any format, like have like whether it's like just generated data that's being used, synthetic data that's being used to train, or whether it's in some ratio with training data. So the effect that we from our experience that we see is that we would have this loss of diversity, right? So we like you said, it's going to be converging towards the mean. So we would see like more generic features compared to like more diverse features. So we would lose the tails, right? And another very interesting thing that we see is that we see this emergence of artifacts that are subject to the algorithms that are being used to generate the data. For example, I can talk about like two different generative models that we studied. So we can talk like there's stable diffusion that has like the diffusion model method that's different from just generative adversarial network that has a different way to train, right? And for both these methods, we've seen this autophagy effect or these artifacts sort of appear. And what we see is that it's subject to the algorithm itself. For example, for StyleGAN or like the generative adversarial network that we've studied, we see that there are these like cross-hatching artifacts that are appearing that are like that could be related to the way these models behave or the way these models learn, compared to diffusion models, which sort of have these blurring artifacts that are coming up. So it's very subject to the models, but we do see this autophagy loop increasing the artifacts in the images. And yeah,
Yep.
it's not only just like something that happens like in the infinite limit. It happens like within maybe 10 or 11 steps, like in a short few steps of autophagy. Yeah.
Yeah, and this applies not only to image generation but to text generation as well. Is
Yeah,
that
yeah.
right?
So there were some concurrent papers who were studying this effect for LLMs. So they've also seen that for large language models, if you retrain or fine tune a large language model with its own data, you would see a similar effect of like converging toward the mean. And the generated data, like slowly, it also loses quality, as in it loses semantic meaning as you continue this loop. So it's a general phenomenon. Yeah.
Yeah, and one thing that people have asked me, and I don't know, so I'll ask you: uh, how much? I mean, the internet is the volume of data on the internet is,
Yeah.
massive. Has anyone been able to measure or estimate how much of that data to date is generative or generate AI generated? And are there any predictions for how that percentage will grow? I can imagine
Mhm.
today it's minuscule, but are there predictions about how that might grow as generative AI spreads through the global economy?
Yeah. Two questions, right? The first one is
Yeah.
what fraction of data is currently synthetic online? It's very hard to like say what is synthetic and what is not. Even like we have these methods to detect deep fakes, and like a lot of technology is being built to be able to detect synthetic data, but it's not completely like infallible, right? So
Mhm.
there's I'm not aware of any studies where they're claiming that such a fraction of the data on the internet is generated, but we've seen that already in the data that's being used to train large models like Stable Diffusion for image generation. We see that in Leon, the large like open source data set that's being used to train these large models already contains some synthetic data, and it wasn't that hard to find. So if we say that,
How
yeah.
how did you find it?
Oh,
That's
so
interesting.
there's a website called Know Your Data.
Hmm.
And there's also like another called Have I Been Trained? So through these websites, you can explore these data sets that are being used to train to see if your image was there or not. So you can search on these data sets using queries, and like it was very easy to like just like one or two queries away, we were able to find some synthetic data on those data sets, like AI synthesized
Uh,
data.
wh- what was the query that you would
So
use?
we use like avocado on a chair. That's like the reason. Yeah,
Oh,
yeah,
right, of course.
yeah.
Yeah.
Like an avocado chair, a chair shaped like an avocado, stuff like that. Like something that
Yeah.
people would
Yeah.
use to generate
That
these images. Yeah,
yeah.
and then we
Yeah.
were able to
Yeah.
find it. Yeah.
Yeah, and that actually, I don't mean to get sidetracked. I do want to get back to the paper, but another question that people ask me and that I can't answer. There are the model builders like OpenAI, Anthropic, and Google,
Yeah.
and whoever, and they're training on data. And people ask me, well, where does the data come from? And I say, well, it's on the internet.
Mhm.
But what are the and then but there's a class of a middleman, uh, data preparers or data prep
Mhm.
companies that are packaging the data into data sets like Lion or others. I mean, Lion is an academic
Yeah.
data set, but there are companies that are doing this. And how are they getting the data? For example, I was talking to my wife this morning about this lawsuit against OpenAI
Mhm.
by Sarah Silverman, the comedian. That's a copyrighted book. How did OpenAI get a digitized
Verse.
copy of that book if it's
Yeah.
copyrighted? Did they did they buy it a Kindle version? I mean,
Yeah.
how does it actually
Yeah.
happen? Do you understand
Yeah.
that?
In my opinion, I think it's just how humans work. Sarah Silverman's book is quite good, and I think that's why some humans had decided to put it on the internet. Like people do
Uh,
piracy all the time, right? There are a lot of websites where there are PDFs, and I think like those are maybe sources from which it might have come into the training data set. So it's like when we are like going out into the internet to just get all the data, it's very hard to say like the way it generally works is like we get an initial set to then scan through and select, right? So that's how like data set
Hmm.
preparation. That's how we do it at Bengali AI as well. We crowdsource we crowdsource an initial set, and then we annotate it or we clean it up. So my assumption is, yeah.
Well, and just let me stop that first step. When you outsource, how is are those just web crawlers scraping the internet, or are people uh, downloading all of the Gutenberg online
Yeah.
library or all of the Google books online, or how w- the
Yeah.
mechanics of getting that data into a data set? How does that
So
happen?
I would assume it's being crawled because it's actually is generally like given the scale at which we need to train these large language models, right? It's actually impossible for us to like have like anything manual in that. That's why like even the Leon data set, they collected like all the images, and then they had like an automated method to score those images and say whether the captions are matching up with the images or not. So these were all automated. They were like, it's very hard to do anything manual there. So if it's like a smaller data set, then we can assume that there could be some manual intervention. But for these like super large data sets, it's mostly like crawled from the internet.
Yeah.
Yeah.
So OpenAI, for example, they don't have. I mean, Google. It's obvious they have the data
Hmm.
through the search engine, but OpenAI, would they have hired a data collection company to go out and scrape the web, and then I imagine there's some prep
Hmm.
in putting it into a format that then can the model can be
Hmm.
trained on.
Yeah, I'm not really sure. Like that's something. It's kind of specific to OpenAI. I'm not really sure whether I know like what they did, but we know from like the public records that they for the RLHF data sets, they did outsource it to some other companies who did collect the like help collect the RLHF data sets or prepare it. Right? So I don't know if it's like
Yeah,
exactly outsourcing or if it's like part of OpenAI because these are big companies, right?
yeah,
So, but I assume that there needs to be like for RLHF, for example, there needs to be the human element because we need the data set to align our models.
right,
But for when we just need like a large chunk of good quality text, I think the manual intervention would be more towards like how we can like curate the text in an automated way. So even that's hard because there can be so many different cases, right? So there can be like cases that you need to handle, maybe like put in fail safes so that you don't really like scrape the insensitive part of the internet where you have like all the like everybody saying whatever they want to, right? Like 4chan maybe, who knows? So
right.
there could be like those are the parts where there could be manual intervention coming in, and maybe like you would need a big team to be able to do that. It could be that they're using like other teams as well.
Yeah, so there would be like a whitelist, not a whitelist, it would be too large, a blacklist, that you cannot scrape from these domains, and then you set your web crawler free, and it's gathering this data, and that then is that data converted into vectors, or is it dumped into a giant text file, or how does what's the next step?
Yeah, generally, the way it should work is so for when you're collecting like when you're scraping data from the internet, at least like at my company, what we do is if we create image data sets, we generally take keep track of the URLs that are being scraped, and then I think even for Leon, when they release the data set, they basically release the URLs. So if someone from the internet, like someone from whose ever like web page, one image has been scraped, if they like remove that image, then that URL is not going to work anymore. So that the data set
I
sort of changes. So that way the data sets are dynamic depending on like the actual owners of the data. And the only thing that the like Leon is releasing are the URLs. So
I
that
see.
is like one method in which like data could be shared. Yeah.
And so and I'm sorry, I'm saying Leon, you're saying
Mhm.
Leon is am I mispronouncing? It's Lyon,
It's
right?
LAION. Yeah.
Okay, Laion.
Yeah.
My
No
mistake.
worries.
Uh, yeah. So Leon, when Leon is it's a list, it's a set of URLs. How does a company or a lab convert that into training data?
Well, they would like then download the data, like download using the URLs that are valid, and then have their own methods to like pre-select which sample they want to use. It could be based on
Right.
keywords or any other like filter that they have.
Right. And is that data then downloaded in the text format, or is it immediately vectorized and put into a massive vector database?
Yeah, these are like very case specific. So these would vary between like
Oh,
some labs, like for some people, it could be like more convenient to have like JPEG images, for example. And then so when we think about such large data sets, there are more efficient ways to store this data, as well as like transfer this between like memory or like between like locations, right? So I'm guessing like it would be very case specific. Yeah.
yeah. Okay, so back to the paper. Uh, the internet is has
Yeah.
some fraction of its content is AI generated, presumably a very small fraction at this
Yeah.
point. But you're already seeing autophagy or this mat effect, or is that only in the testing that you
Yeah.
do with in a
Yeah.
closed
Yeah.
system?
Great question. So we don't see. So it's so the autophagy is very interesting, as in like the effects of autophagy or the symptoms of autophagy, they come up late, even after like autophagy has been happening for a while. So we don't necessarily see symptoms of autophagy, or we haven't really like we haven't even like very rigorously explored as well, like if stable diffusion has any autophagy effects. It's not. It's kind of like non-trivial to see like if there are autophagy effects over there. But we do see that like in our controlled experiments, when where we are using the same algorithms used to train stable diffusion, the same algorithm behind like generative models. When we do those controlled experiments, we do see that autophagy is happening in a few steps. So there are like three different sort of settings which we explore. So one setting is where we're like completely training a model using its own generated data. So we take suppose some generative model, we create some data, and then we take another like we start from scratch. So we retrain another similar generative model using that generated data and see like what the effects are. So this is like the most extreme case, and it would be relevant for like I was saying, like people who want to use just synthetic data for privacy purposes, right? So that is where we would see like the strictest form of autophagy effects coming up, right? So we would see very fast decay of the diversity, and then we would see these artifacts come up very like way faster. Another setting would be where suppose we have like some training data set that we are always going to use, so we always have this fraction of real data, but then we are going to create synthetic data to like and augment the original training data that I have.
Yeah.
And the reason a lot of people actually have been thinking about this is because, like, if you think of, suppose that like we have two different images, like one is my image and another is your image, right? And then you want to like there are a couple of images between these two faces. Like if we think of interpolating between my face and your face, then we would see like there can be like a continuous change in the facial features that I have that maybe would slowly lead to your face, right? Um,
Right.
so if we have a generalized generative model, then a generalized generative model by definition should be able to do this interpolation. It has learned the data manifold, so it knows like how to go from my face to your face. Right? So a lot of people, what they've been thinking of doing is like using generative models to create these intermediary faces compared to what you have in training data, right? You have like when you generate synthetic data, you would get these intermediary faces compared to what's in the training data. So that might help
Yeah.
in training a newer generation of models. But these people have been thinking of using synthetic data as well. So over there, what we see is that the autophagy effect does exist, but it's not as sharp as just training on synthetic data, but it doesn't stop autophagy from happening. We do see that if we
Mm.
have a fixed training set, if we keep generating more synthetic data, it's going to slowly decay towards like madness. Right? One small thing that I wanted to mention is like the term mad comes from, like, it's actually very much inspired from the mad cow disease. Because yeah,
Oh,
because
yeah,
we
yeah. Woo.
like some person had
Yeah,
the smart idea that, okay, let's feed like cow brains to other cows or something, right? And then
yeah,
the like it maybe it was a good idea at first, but then it turned out to have the self-consuming loop led to some very bad effects. So
yeah, yeah.
so that
I mean, it's also it's the same principle in in incest or narrow gene
yeah,
pools
yeah.
or small gene pools where yeah the so first before we talk about how you might deal with
Mhm.
this uh so you're seeing it already. You were saying these hash marks in
A
was it
Stalgan, yeah, it was
diffusion
a Stalgan generation. This is
or
like a
GAN, yeah,
yeah.
style GANs, yeah. Is do you is there some metric about how much uh and I understand it's model specific and algo specific, but that once you reach 2% or 5% or 10% or 20% of generative data, you're going to start seeing this effect, or can you is it impossible to say?
Oh, the percentage of generated data versus like real data, right?
Right,
Yeah.
versus real data.
Yes.
Yeah,
So yeah,
sorry.
that is like a very important thing that we want to explore in the future, and we've done some explorations as well. So the most important takeaway there is, um, we can have some ratio of real and like synthetic data, but the most important thing is we need fresh real data compared to just having some ratio of real data. So some ratio of fresh real data is what can actually help us sort of like nullify the effects. Like maybe asymptotically, we are doing more studies here, but asymptotically we could have like a situation where like this percentage of fresh real data on every loop would basically keep delaying like the mad cow effect to like asymptotically, right? So we will never reach
Right.
like autophagy. Um,
Yeah.
yeah.
And the in terms of the internet, because of course the popular mind, the layman's mind goes to, wow, all of this generated AI generated data is going online. Maybe in 100 years, 90% of the data online will be AI generated, and then this autophagy will really be a
Yeah.
problem. Is that something that you guys have contemplated? Is the growth of generated data so high with regard to the generation of real
Yeah.
data that's possible?
Um, if we want to compare the amount of real data being generated and the amount of generated, like synthetic AI synthesized data being generated, um, there's obviously like more people, like there's more real data being generated. There's no question about it right now.
Right.
But like the thing is that the direction that we want to go towards is people adopting these technologies to, yeah, to like help generate, like to help write better maybe, or help with the image that they're trying to create, right? So we want people to be adopting this. So we want all the people in the world to slowly start using these generative models, and that would be beneficial in so many domains. I think that is why like it's we can it's not like a scenario that's sort of sci-fi, right? It's almost here. Like we have like a lot of different websites that are completely generated. Like there I think there was an article, I don't know if it was New York Times or Guardian, where they were reporting that there are like these fake news websites which are which are completely generating data using LLMs, right? So we already have these sources that are creating these websites, like only creating synthetic data, and we have people who are using like millions of people using ChatGPT to write better, right? So slowly,
Mhm.
like from this point on, like from the ChatGPT going public for use and then onwards, we're gonna see a shift in the language that's being uploaded online, right? In the way things are being written,
Yeah.
and
Yeah.
we want it to be adopted more. So we'll see this effect grow as time goes on, right? So that's
Yeah.
why that's why we need to think about this right now, as in like, okay, so the new generation of GPTs, maybe GPT-N, when we try to train it, maybe after training we'll see that it's very formal. Like it sounds very formal because for the past 10 years people have been using GPT like technology to write like more formally or in a very nicer way, right? So
Yeah.
those effects would start coming up, and for us to not like meet that point where like our performance is getting saturated, right? We want to start thinking right now like how we can like deal with this probable phenomena that we're going to see.
Yeah. So what are some of the uh, strategies that you might pursue that could deal with this?
Yeah. So like I was saying that there's the idea of having fresh new data, which can be one strategy of mitigating the mad phenomena, right? Another way could be like another easy way that we should like try right now actually is just watermark the data that we are generating. Like we
Right.
already see like when DALI was released, DALI had that like sort of the multicolored watermark block right at the bottom, right? And there's also like this, like recently Google announced that they'll be using SynthID on all of their generated images. So SynthID is basically they put in some really imperceptible like watermark into the image that you can use to like see like that's something I think is also being used in YouTube and a lot of other like where people are uploading their like content to be able to like monitor if it's being copied or something, right? So SynthID is also going to be used in generated images. So that's like another thing. There's a lot
Mhm.
of research going towards watermark. So watermarking could be one way to detect these images. But then if we want to use any of these watermarks, so there's this dilemma. If we want to use these watermarked images to train generative models, we have forcefully added this noise into the image, and then we're using that to train the model. So that's gonna increase the autophagy effects, because autophagy basically it exaggerates these hidden artifacts. That's why we see this cross hatching coming up in StyleGAN too.
Yeah. Yeah.
So there
Yeah.
is this dilemma of okay, watermarking, and then okay, so now we can detect synthetic data, but autophagy might still happen. So then we need autophagy aware watermarking, meaning that once we detect the watermark, we should be able to remove it as well before using it for training. So that we have like the actual information intact. So this can be like an interesting, this would be an interesting dynamic field to like sort of do research in. A lot like adversarial like attack research. If you're aware, like neural networks, like for some imperceptible change in the input, can behave completely differently. And
Yeah.
the way
Yeah.
it became such a like a the way the field was explored, or the way it flourished, was there are a lot of people working on attack methods and a lot of people working on defense methods. So then there could be there can also be like in terms of these autophagy effects, there could be a lot of people working on watermarks and a lot of people working on like removing the watermarks to like mitigate the effect of watermarking on like autophagy, right? So this can
Yeah.
be like interesting. Yeah.
Although the point of watermarking would be in order to exclude those things from the training data,
Um,
right?
like you might want to keep like I was saying, like there could be some benefit of having some synthetic data in your training, as long as you have fresh real data, right? So you
I
might
see.
want to keep some synthetic data, maintain that ratio compared to your fresh new data that you're getting, and then try to retrain. And that's how we will get like keep getting better, because we want to keep getting better. That's the target,
Right.
right?
That's right. And the fresh real so but in any case, watermarking, and I just interviewed the I can't remember, he's the CEO or CTO of Digimark, who's the biggest watermarking company in the world, and then Scott Aronson, uh, who's computer science out of Texas, who's working on safety for OpenAI. He's working specifically on watermarking text, which is obviously much more difficult by
Yep.
creating statistical patterns in the generated text that can be recognized by another system. But uh, watermarking would be a way of excluding data, synthetic data from training sets, or at least knowing
What
uh,
ratio or
what
yeah.
ratio you have. Without that, there's really no way to know, right?
Yeah, without that, like there are like without watermarks, it's there are gonna be ways to maybe find out what synthetic, like there are ways that are there right now, but as we keep improving, it's gonna keep getting harder, right? So
Yeah,
that's like one aspect of it. So there could be like other methods to like control this as well, because this is a new phenomenon that we've observed, and there are a lot of like research groups who are starting to like jump in and study this phenomenon. So
yeah,
yeah,
uh, be,
yeah,
yeah, because uh, finding synthetic data to train a model on is, is fairly straightforward. Uh, Once the internet is polluted with synthetic data that's not watermarked, it'll be very difficult to find fresh, real data, right? And it's obviously not practical and would be too costly to generate real data just to train a model.
yeah, yeah. This is a very good question. I think there might be like something in the maybe companies in the future they decide, okay, we're going to generate our own data, and like maybe like when I think about this situation, I like the first thing that comes to my mind is Matrix. So in Matrix we have like
Yeah,
humans generating something for the machines, right? So it could be that we have like a situation where we want to generate, like companies might want to generate their own data. Could be for privacy purposes. Could be just to get the fresh, real data that we need to keep on accelerating. Because we do see this exponential growth, but because of such phenomena, it could be that we saturate, and then we would need to do interventions to keep growing, keep getting like better models, right? So.
yeah. And when you say saturate, this is another thing that somebody was asking me this morning. Actually, is there a point at which so the LMs are right now training primarily on public data on the internet. Is there a point at which all of that data would have been used to train a model or models? And does that create some sort of a convergence between models, even though they're owned by different companies? If they're all being trained at some point on the same data.
Yeah, that's a very good question. Yeah, the convergence of models to one sort of to a similar, like it's very hard to like sort of say whether like two different algorithms are going to converge to the same point or not. Like it is intriguing that using the same data, that could be a case that happens, but we've seen that for a lot of the like the open source models that we have. That's why I think open sourcing is so important. So that because we have these open source large language models, and because people are like doing studies on these models, like we've seen that there are a lot of different tricks you might also have to apply to get the utility out of your network. So just training on the data might not be the be all to get the performance that you desire. So there are, I think there would be the aspect of like a recipe as well, apart from having the data. The data and the recipe together gives you like the perfect dish of like an amazing large language model. I think, yeah.
Yeah. Yeah. And then there's the other, I've started talking to people uh, about other AI architectures or strategies beyond
Mhm.
generative, pre-trained transformer models. I mean, there is that is people. It's certainly in the popular mind today. That is AI, but there's AI is a very large field. Um, the and just another question related to data collection. Uh, and probably you won't be able to answer it, but you certainly could take a stab at it in a more educated way than I could. OpenAI, GPT-4, for example, uh, has that. What percentage of the internet has that consumed in its
Oh
training?
wow.
Do you have any idea?
I don't think anybody has any idea like other than OpenAI, because with the rising trend of like companies, they don't want to share the information
Right.
that of how they're building their flagship products, right? So like apart from
Right.
Meta, who's like releasing everything, like I'm completely pro open source. So there's I'm gonna add something about this a little while later. But to answer your question, like it's very hard to say like how much they're using. But I would assume they're trying to use all the good quality data that they can get. Yeah.
So, and let's talk about llama then, because uh, again, you're pronouncing it different than me. Is it llama,
Uh,
not llama?
it could be llama. Yeah, that's yeah, that's something. Yeah, I'm
Yeah.
not sure like what the perfect pronunciation for llama is. Yeah.
Yeah. But is it possible at this point, or very soon, it will have consumed all of the internet?
Um,
The not the dark web, obviously, but the public internet.
yeah. Like there's gonna be this limitation. Like it also like requires some time to train these models. So suppose like you're in 2021 and you take all the data and you start training your model, and then like it'll need some time to develop your model. So it'll take 1 more year. So you'll always be in a situation where you're maybe behind by a year. Right.
Right.
So
Right.
that's what we see in ChatGPT as well. We have like data up till 2021.
Right.
So I think that effect would be there. Like we would not always have like the like everything consumed by a network. Uh, but yeah, I think like any good amount like good text that exists, I think these models would be using it. The social media companies, so social media data is very different from the data we have online in terms of like in the blog sites in like Wikipedia and stuff, right? Social media data is very unstructured, and it can be very like it's very hard to sort of quality control. Like from my personal experience, like from our
Sure.
company, when we work with social media data for like we generally what we do is we crowdsource data, and we open source them to crowdsource the solutions as well. The way we crowdsource solutions is through competition. So we have like a Kaggle competition running right now for like $50,000 prize money on Bengali speech
Hmm.
recognition. So we basically crowdsource the data online by through influencer campaigns and through like targeted social media campaigns, and then we just crowdsource the solutions through this competition, right? So in these settings, when we are crowdsourcing data, if we ever try to crowdsource data through social media, we always see that it's very unstructured in the sense that like in social media it's very hard to control for like that's naturals like more natural text maybe, but more natural text is like it has like a lot of like bad words, it has like transliterations, it has like code switching and like spelling mistakes, so many different things, right? So it's harder to work with social media data. So maybe like it could be that like the social media data that exists in out in the public to be used for training. Maybe the companies will work towards like other. Maybe they already have methods to clean that data up. Like so, it's going to be case specific. Like social media data would have to be handled differently compared to Wikipedia data or something. But I
Yeah.
think people would be
Yeah.
doing that to get more good quality data to train.
Yeah. And then you were going to say something about LLMs. I
Yeah, yeah,
have
yeah.
another question, but I don't want you to forget what you were
Oh,
going
I
to
was
say.
I was talking about like the openness, like the like
Right.
open sourcing. I feel like is so important. So there was a so there's an archive paper that David Donahoe, who's like a legend in the field, he posted a couple of days ago, where he says that so he takes a stab at the existential crisis question, right? And
Yep.
what he says is like, and which resonates with me so much is that there are three things that have accelerated this field, and those three things are also it's also gonna ensure that we don't have a situation when we are like gonna like not exist anymore, right? And the three things is like code sharing, sharing code and recipes between like people, like free code sharing. The second thing is data sharing, which we have like in all the like all in everything in AI has like happened because of data sharing. Like, we have ImageNet, right? Like someone open source that like Feifei like has completely changed like how like completely accelerated how computer vision progress. So and the third is competitive like competitions. So these three together, like sharing large language, like if we think of large language models, sharing the code and data for large language models, as well as like sharing the code and data for these like uh, like for generative model, like stable diffusion as well, right? So these I feel like are very important to be able to assess these networks, so that we can actually tackle like any existential crisis question that can come up in the future, right? So yeah,
That's interesting. That's interesting. The question I was going to ask is about open source because I've been debating with some very smart people on this, uh, who take the view that uh, open source will not dominate because there's too much value creation in proprietary models. And the real and in order to create that value, you need tremendous financial
yeah,
resources. And the open source community will never have resources to match uh, the proprietary models. And certainly Meta is the exception, but the question is whether or not Meta will continue to invest in open source
hmm
models. And there's a big question mark as to why they would do that given the cost. And then there's, that's interesting what you say about the existential threat, but these models are extremely powerful once they're open source. People can remove the guardrails and do whatever they want with them. And I mean, I think Jeff Hinton, or at least Joshua Bengio, quoted Jeff Hinton as saying, would you open source nuclear weapons? It's too dangerous to hand to any potential malicious actor out there, and unfortunately, there are a lot of them. So, how do you feel about that debate? First of all, do you think open source can marshal the resources to dominate or at least compete with proprietary models? And two, what about the dangers of open source?
yeah. Like working in the open source domain, like myself, I think I agree with this partially, that it would be very hard for open source to match the performance of proprietary models, because like open source efforts is basically community efforts. So wherever you
Hmm.
need capital for like making something better, the closed source models are going to be better, right? They have more. So suppose like we run out of real data on the internet. Only the big companies have enough capital to like hire teams to create new data. The
Yeah,
open source efforts, it might, so it could be that some big company does that and open sources the data. So that would be completely on them. But just for the open source models, in like what the development that's happening with open source models right now, it might be like, obviously it could be hard to like compete with the like the proprietary models, right? But the benefit is not in performance when you open source. So the benefit is in understanding what these models are doing. There are so many research groups who are studying the open, like Llama 2, for example. They're studying these large language models to see like when they're failing, why they're behaving this way, how to interpret them better. And when something is open source, like it's theoretically you have like n number of heads who can work on this
right,
problem, right? Compared to when you're in a company, you have like you have the number of heads is limited by the budget that you have to hire people, right?
right.
So
Yeah,
it's always going to be like open sourcing models is always going to allow more people to solve the problems with AI that we see that could harm people, or that like them like having bias. So there are people studying the bias in networks. That's fine, and they're being able to do that with the open source models, right? So I think open
that's
source
right.
has the benefits in that direction, compared to like maybe they won't be able to match the performance of proprietary data, proprietary models someday, but they'll be able to help the people working with proprietary models to make decisions on how to make them better as well. Like it benefits everyone,
Yeah,
benefits humanity. Like better models help everyone.
yeah,
Yeah, I
yeah.
think that.
It's interesting on the dangers of open source. Uh, I don't remember how long ago, a couple of years ago, I interviewed a guy named Connor Leahy. Do you
Yeah.
know him? From he started Eleuther AI, an incredible organization that is now incorporated. But at the time, it was a totally decentralized group of hackers on Discord, and I think it was when GPT-2, maybe it was when GPT-3 came out. they said, "Hey, let's build an open source," and they built GPT-J, and now they have Neo. I can't remember the name of the models that they have now, but Connor became so freaked out by the dangers of these models being not only existing but being open source that he quit Eleuther AI, and has a startup now that works on the alignment problem on AI safety. What do you think about the danger of open source, of having turning these powerful models over to whoever wants to use them?
Yeah, like without a doubt, there are so many risks involved, right? Like when we open source really strong models, like we see fake websites full of text that's being generated, right? Fake news. These are going to be like super easy. Spamming people, like you can like generate emails and just send millions of emails out. Like we had the Nigerian prince before. Maybe now we have like the AI overlord from Mars who's sending emails to everybody, right? So
Yeah.
there could be like these situations can happen, but like so this is my belief completely. So what I'm gonna say now. So I believe that when we think of like when we open source, we send it out to all everybody, right? All of people. And when we have such big number of peoples, the law of large numbers should come into play, right? So we would have some modal tendency of doing something, and then we would have like tails. And I believe that
Right.
humans in general, we the mode should be towards good, because humans
Yeah.
we to survive in society we have to like talk nicely with other people, right? And we have to behave nicely, we need to help others so we can get help, right? So I think like because of that reason when we open source the mode would be towards good, but there are always going to be people towards the tails who would want to do bad with it.
That's
And
right.
then comes the question, how much resources do these people have? So if we have
Yeah.
bad actors with a lot of resources, that's when bad things can happen. Like if you're talking about like open sourcing nuclear missiles, right? So if you have someone who has like the capital to build like nuclear missiles, like they have access to uranium and all the everything needed to build them, that's when it becomes so dangerous, right? But then if you don't have access to that, then it's just, yeah, I have another piece of paper that says like how to make like a bomb, a big bomb or something, right? So I feel like it's gonna be subject to that person, to us humans. It's gonna be on us humans who have, especially who have capital, right? Who have the capability to use this in a bad way. We would then, that's when we need to like, that's where we need to think about like, okay, so uh, as long as the people who want to do good are like being able to like maybe triumph over the people who are trying to do bad, as long as FBI is like hunting all the people who's like using this to do maybe like the worst possible things on the dark web, like the good will triumph, the mode will be towards the
Yeah.
good. So that's my
Yeah.
belief, that's what I think. Yeah. So what we like this idea of self-consuming neural networks. Like we have these amazing collaborators on this paper, especially the like I must mention the first two authors, Sina Ali Muhammad and Josue Casco Rodriguez, who like literally spearheaded this research and brought these amazing insights out. So like everybody go check their papers as well. They're like amazing researchers. Yeah.
AI might be the most important new computer technology ever. It's storming every industry, and literally billions of dollars are being invested. So buckle up. The problem is that AI needs a lot of speed and processing power. So, how do you compete with costs spiraling out of control? It's time to upgrade to the next generation of the cloud, Oracle Cloud Infrastructure, or OCI. OCI is a single platform for your infrastructure, database, application development, and AI needs. OCI has 4 to 8 times the bandwidth of other clouds, offers one consistent price instead of variable regional pricing, and of course, nobody does data better than Oracle. So now you can train your AI models at twice the speed and less than half the cost of other clouds. If you want to do more and spend less, like Uber and Cohere, take a free test drive of OCI at oracle.com/ionai. That's EYEONAI, all run together. That's oracle.com/ionai. That's it for this episode. I want to thank Ahmed for his time. If you want to read a transcript of the conversation today, you can find one, as always, on our website, eye-on.ai. And remember, the singularity may not be near, but AI is changing our worlds, so pay attention.